Okay, Algebra 2. This is going to be the last set of notes in the kind of the exponential log unit that we've been doing for the past couple weeks. This one's kind of a long one, so I'm sorry. But today's 3/19/2020. I'll have a blank copy of these in Google Classrooms if you want to print them and go along with them, or you could just write it down, or you could just watch the video. Okay. So now we're going to solve with log equations. On Monday we did the log properties, and one of the properties was the equality property. And then Tuesday, Wednesday, we didn't really use the equality property, we were just using the other properties to condense and expand. But now we're using the equality again. Okay. So when you're solving log equations, there's going to be three scenarios, and we're going to do a couple problems from each scenario. The one thing you do want to remember for all of these, especially in your answers, when you check your answers, is that you want to remember that you can't take the log of a negative. Okay. So we've ran into this a couple times where you do everything right, but then one of your answers doesn't work in the equation. Okay. So in this case, if we get anything that makes our logs negative, or the input of our log negative, that's going to be an extraneous solution. All right. So the first scenario, the easiest one, is that if you already have two logs with the same base, okay, then you're just going to use that property of equality. Okay. Property of equality stated that if you have two logs with the same base, and there's one on the left side and one on the right side, then you could just get rid of the log portion and only look at their arguments. Okay. So you got log base 2 equals log base 2, which means this input and that input have to be the same. So you just get rid of the log portion and you're just left with x equals 14. So that's the easiest version we could have. It's just x equals 14, so x equals 14. That's the answer. Unfortunately, they're not all this easy. Now the one below it, part B, you have log base B and log base B. Okay, there's one on the left and there's one on the right. So we could kind of ignore the log portion of it and just look at the argument portion. Okay. So now it states, using the power of equality, the property of equality, x squared equals 2x minus 1. Okay. Alright, now this is a quadratic, and the only way we could solve quadratics is to factor them. So we're going to have to move everything to the other side. Subtract 2x and add 1 to both sides. It's going to give us x squared minus 2x plus 1 equals 0 on the right side. So now we have a standard form quadratic on the left. Whenever you see a problem like this, always think factor. If we're going to factor the left side, just use product sum. What multiplies to 1, what multiplies to the last term and adds to the middle. The only thing that multiplies to 1 and adds to negative 2 is going to be negative 1 and negative 1. Okay. Equals 0. So now you would use the zero product property and set each of these equal to 0. Now since they're both the exact same, we only have to do it once. X minus 1 equals 0. So x equals 1. Okay. Now if you remember when we talked about polynomials, there's actually two versions. There's two x equals 1s. So that's a multiplicity of 1, or multiplicity of 2, which means on that graph it would bounce on the x-axis. So we'll call back to some old material. Okay. Alright, and this last one, when the log's bases are the same, again, log 5 equals log 5, so that means x squared minus 30 has to equal x. Now once again, this is a quadratic, and in a quadratic to solve, we're going to have to move everything to one side. So I'm going to move this x over, leaving me with x squared minus x minus 30 equals 0. Factor that. What multiplies to negative 30 and adds to negative 1? Well, it's going to be negative 6 and positive 5 equals 0. Use the zero product property. Set each of these factors equal to 0 and solve for x. So x minus 6 equals 0. X plus 5 equals 0. So x equals 6, or x equals negative 5. But again, be careful. These are the answers, and no, we didn't do anything wrong here. The problem is, if x equals negative 5 and you plug it into this right side of the equation, you're going to end up with log of 5 of negative 5, and we can't take the log of a negative. So this one actually isn't an answer. It's extraneous. So our only real answer is x equals 6. So always just take an extra second and check your answers. Okay. All right, so that was scenario 1. It's not that bad. When the bases are the same, just get rid of the log portion and then figure out how are you going to solve that equation. If it's a linear equation, you just solve for x. If it's a quadratic equation, you're going to have to factor and solve for x.